All right, so for 5.7, we are dealing with this idea of CPCTC, CPCTC. And this is what I had you write down in your notes beforehand. CPCTC, even though it doesn't use this abbreviation in the book, this is what most geometry books and geometry people use as the abbreviation. This is saying that corresponding parts of congruent triangles are congruent. So we see that abbreviation, CPCTC. So we're going to use CPCTC as a step in a proof, as a reason in a proof. You'll see it on the orange sheet. We saw it in our ICANN statement when you looked at the sheet before you guys left. CPCTC, and this is going to be the step after we prove triangles congruent. Okay, this is the step after proving triangles congruent. Because once we know that we have congruent triangles, now we can say that all the other corresponding parts have to be congruent. So we're proving triangles congruent first, and then we can say, all right, everything else has to be congruent too. So that's going to look something like this. If we have, let's say we have this figure, right? We have enough information right now to prove that those two triangles are congruent. All right, we have HL. By reflexive property, we have the fact that they are right angles, and we have the hypotenuse is congruent. So we have enough to prove the triangle is congruent. What we can do then, we give it some letters.
Mr. Gadowski?
Yeah.
How can you say that ABD is a right angle? There's nothing saying that's a straight line. That 180.
Then this is a straight line?
There's nothing saying that's a complete 180 degrees. It could be.
We assume that it's a straight line. If it looks like a straight line, we assume it's a straight line.
Okay, because I was just thinking it could be 181 degrees or 179.
Right, yeah, and they won't do that to you. If it looks like a line, it's gonna be a line. Yeah, yeah, we have to assume there. So we've got, these are congruent, and what we can say now, after we've proven that these are congruent using HL, what we can say now is something like angle A and angle C are congruent. Right? We can now say that AD and CD are congruent. We can state all those other pairs. Remember when we started, we did definition of congruent triangles, and we had 6 pieces of information, right? 6 things were congruent. 6 pairs were congruent. We only used 2 or 3 to prove the triangle is congruent. Once we know those triangles are congruent, we can say all the other pairs are congruent now too. And that's the reason for that is CPCTC. Okay, so we can now say, because we know these are congruent, we can say that these two are congruent. I can say that these are congruent. I can say that these are congruent. Right? So once I know that the triangles themselves are congruent, I can say all the other pairs are congruent as well. Right? That's what we're looking at today.
So your reasoning would be PCTC. What would your actual equation be on the left side?
It depends on what they're asking for, right? What you're trying to prove today, you've got your givens and your proof. What you're trying to prove might be trying to prove that angle A is congruent to angle C. And so we'd have to prove the triangle's congruent first. And then after those triangles are congruent, our next step would be A is congruent to C because of CPCTC.
Okay, that makes sense.
All right, so let's take a look at some problems that we might run into here. All right, let's see. So let's look at up on the top here. Up on the top, and what we're trying to see is, do we have enough information? Do we have enough information to prove that NP is congruent to LK? So that's what I want you to look at. Think about it. Do we have enough information to say NP is congruent to LK?
Yes.
Yes, we do.
Yeah.
Yeah, we do, right? We have vertical, right? We have vertical angles here and right angle congruent. So ASA means the triangles are congruent. Once I know the triangles are congruent, then I can say CPCTC, these two things have to be congruent as well, because those are their corresponding sides, and they have to be congruent in congruent triangle. Okay. Haley, to answer your question, it will not always be the end of the proof. Okay, a lot of times it will be, but not always. There might be one that we take a look at in a little bit where it's not the last step. It will always be after triangles congruent, for sure. It's always the step after triangles are congruent, but we might do something after it as well. Okay, so I can't say for sure that it's going to be the last step. All right, so let's look at a couple things here. Because really, guys, that's the whole idea behind today's CPCTC, right? There's no other theorems, there's nothing. It's just this idea of we can take that one step further than we've been going. So if we look at 4, okay, think to yourself, how would you prove that Q is congruent to T in this?
Wait, am I allowed to say it?
Let's give it a couple seconds.
Oh,
Then you can
sorry.
say it. You're good. All right, Weston, what do you got?
You can use vertical angles to prove that angle P is equal to angle P, and you could say side angle side, and then they're congruent. So, and then angle Q is not equal to angle T.
Yeah, so we would have the givens, we would have vertical angles, then we'd have SAS, and then after that would be CPCTC to say that these are congruent.
Yeah.
Mr. Kudowski,
Yeah,
to find the angle of P, you can also use reflexive property, right?
you are not allowed to use reflexive there because it's not the same angle, right? And technically we can't just call it angle P and angle P, we would have to name it with the 3 letters. We would have to go QPR and TPS because we're talking about 2 separate angles there.
Okay, thank you.
So let me also point out to Haley's question earlier. Let's say I'm not trying to prove that. Let's say I'm trying to prove that RQ is parallel to ST. This is something that we could run into. Trying to prove that the left and the right are parallel. Well, we're going to go through the same steps. We're going to do vertical. We're going to say that the triangles are congruent. And then if we show that Q is congruent to T because of CPCTC, now that I know those are congruent, I have enough information to say that these lines have to be parallel. What's my reason why these 2 lines are parallel now?
Because of AIA.
Close, you're missing a word.
Would that to be the converse version, or?
It'd be the converse, yeah. Remember, converse proves lines parallel. Yep, yeah, you're right on it. It's that Z shape. It's just if we're going to prove lines parallel, it's going to have to be AIA converse. So that's where we would have in our proof, right? We would have all of our steps. We would have the triangles being congruent. We would have angle Q being congruent to angle T because of CPCTC. And then we would still have another step after that, which would be what we were trying to prove. RQ is parallel to ST, and that would be converse of AIA. Okay, so all that stuff that we've done in the past still applies, right? That's why we have that orange sheet, because all of those things come into play, right? We're going to have those converse of AIA. We're going to have proving lines parallel, along with the triangles here, right? So we just got to be ready to go a little bit further and bring in some old stuff compared to what we've done the last couple days. Okay. All right, let's look at another one here. Let's go. We look at 6. Okay, take a second, think about it. And basically, guys, these are all going to be just like what we've done the last couple days, which is how can I prove the triangle is congruent? And then it's either, you know, it's one extra step or 2 extra steps. Saying, all right, because these triangles are congruent, we've got CPCTC. But you're always still going for triangles being congruent, right? That's still the goal in every single one of these problems is how can I get those triangles congruent? All right, what do we have for triangles congruent here?
You can use I think AIA to make angle CDB congruent to BAC, I think.
That would be these big angles.
Oh,
That's not going to work. You're on the right track. We are using AIA, but not for those big angles.
You have to say
I-
that CDA is congruent to
right, yeah.
BDAB, and then you can use reflexive property to say that AD is congruent to DA, and then you can use AAS.
There you go. Yeah. So, and guys, this is where you'll notice if this was truly a proof, and we were trying to prove this, they didn't give you a congruency statement between these 2 triangles. So this is where we would have to create our own congruency statement, and it would have to be a good congruency statement. Things would have to match up, right? So this is why it's important to be able to write things in the right order, because things are going to have to match up. They're not going to give you that congruency statement anymore. You're going to have to come up with it and make sure that things are written in the right way. So if we say CDA, right, from the 1 arc mark to the 2 and up, we got to go BAD for the other one. Okay, so we got to pay attention to how things are labeled. So yeah, once we get those triangles congruent, now it's simply CPCTC. Because these triangles are congruent, I can say that those 2 corresponding parts are congruent. So AC and DB are congruent. Okay. All right, any questions on that? Because really this is, like I said, this is it, guys. This is a perfect lesson for a short day, because it's just taking it that one extra step and being able to say CPCTC, all those other pairs are congruent now. Okay. Any questions? Sounds like a no. All right, so apparently he just had enough. He was out. You got 10 minutes until third hour, right? Third hour starts at 9. This afternoon, I will be on Zoom from 12:30 to 1 for second hour. So if you have questions, you can jump on the Zoom then, 12:30 to 1. I'll be available for you. Whether it's questions on this or other stuff, whatever you got questions on, I can help you then. Okay? Otherwise, I'll see you tomorrow.
Bye.